Hey, sixth graders. Second to last week of school, so only two more. Um, we're gonna finish up our weather stuff this week, so you have to finish your project. You had a choice of projects to choose from. That project is due this week on Friday. And we are gonna move into climate and the difference between climate and weather. So, without procrastinating too much, here is our notes. So our notes are on climate. So what's the difference between weather and climate? Weather is the day-to-day conditions of uh, the atmosphere. You can think of this as like each day you're thinking about temperature, precipitation, wind, um, sunshine, things like that. That's the day-to-day conditions of the atmosphere. So that would be like a storm, because that happens on a day-to-day basis. A sunny day would be weather. The difference between weather and climate is that climate is the average weather conditions from year to year or even longer than that. So usually when people talk about the climate of an area, they're talking about the long-term average. So like maybe over 30 or 50 years. So um, some things people talk about when they talk about climate are like the average temperature. So um, this would be all of the temperatures, let's say for a year, you add up all the highs for a day, right? For each day. You add all those up and you divide by 365, right? Because there's 365 days in a year. That would be your average temperature. It's like it could be one day is really hot and another day is really cold, and it'll average out to be somewhere in the middle, right? You could do yearly averages. You could also do monthly averages. This is where you take the sum each day and divide by 30 days or 31 days in a month or 28 days if it's February. And that'll give you your monthly average. So basically, what I just want you to get from this is weather is day to day. So a hurricane is considered a weather event, but maybe the average number of hurricanes in a season, that would be a climate event, right? We're averaging out these events over time. Okay. Some other things that scientists use to talk about climate is the temperature range. So this is a really easy calculation to make. This is where you take your highest average minus your lowest average. So you would average out the high for each day of the year throughout time, right? This takes a long time to figure out. So you would take the high, the average high each day. So you would take your highest average minus your lowest average, and this is your range. So in Minnesota, let's look at our temperature range. So if you look at, let's just look at Minneapolis because that's what pops up. They take an average temperature each month. So if you look here, they take an average temperature each month. Um, and you have your warmest month, which is going to be July. The average high is 83. And then you have your coldest month, which is January, which is the average high is 24. So to get your temperature range, it would just be 83 minus 24, which is, let's see here, 83 minus 24 is 59 degrees. So that would be the temperature range for Minneapolis. The other thing they talk about when discussing climates of an area are the average precipitation. So the average precipitation is just the same as you calculate temperature, only you're looking at how much rain or snow you get. So you would put out a rain gauge like this bird is sitting on over here, and you would measure how much rain you get each day. Then you would take your average, maybe for the month. So maybe you measure the rain each day for the month of April, and then you divide by 30, and that would be your average precipitation. And this shows like how much precipitation do you usually get per month or per year in an area, right? So it could change year to year, but on average, this is what you will usually get. Same with temperature, right? So temperature, that would be the average temperature would be what you can usually expect for an area. It could be higher some days, it could be much lower some days, but on average, that's what you can expect. So this map here shows weather, because this is one single day, right? It shows the weather on March 5th, 2017. This would be one single day's weather. It's showing precipitation in the Pacific Northwest. It's showing some rain down in Texas. It's showing pretty clear conditions in the middle of the country. But this doesn't show the average for everywhere in the country over time. This shows one day's weather event. This, on the other hand, is a climate map. This shows the average temperatures for the country. So your darker reds are going to be hotter. Then it progresses to orange and yellows and greens, blues, purples, and pinks. So this shows the average temperature in the United States. So this is taken over many, many years. This is usually these averages are taken over 30 years or more. So if you see here, this would be a climate map because it shows the average. This is what you can expect in an area, but day to day it could be different. So the average in northern Minnesota would be 32 to 40 degrees Fahrenheit. Here in central Minnesota, the average is 40 to 45 degrees. As you go lower, if you look at Florida, the average high is over 70 degrees. But these temperatures could change day to day. This is just an average. This shows what you could expect on any given day in this country, what the temperature would be the average. So there's some different factors that determine climate. Based on where you are in Earth, you can have different climates. So one determining factor is latitude. So this just means if you're closer to the poles or to the equator, right? Latitude is where you are as you go up from the equator towards the poles. Latitude determines how much sunlight you get, right? So in the poles, we get much less direct sunlight. At the equator, we get lots of direct sunlight. So how much sun or how much heat you get determines on what latitude you are, right? In Florida, they get more sun or more direct sun and more heat than Minnesota. So they're going to have a different climate, right? They can have palm trees and alligators and stuff down there because they get more heat. Up here, we have different plants and animals because we're colder. Another thing that can determine your climate is the altitude. So as you get higher up in altitude, your temperatures get colder. So if you've ever been out west and you've been up in the mountains, you know that if you start the day at the bottom of the mountain, it's going to be, usually in the middle of summer, it's going to be fairly warm. And as you go up that mountain, it can get really cold really fast, right? That's why mountains in Wyoming still have lots and lots of snow, because it gets colder as you go up in altitude. And altitude is just how high you are sea level, right? 0 sea level would be really low altitude, and some mountains in Colorado have 14,000 feet elevation. Well, that would be a higher altitude. Ocean currents can also affect the climate of an area. In winter, oceans keep places along the coast warmer, and in summer, oceans keep them cooler. There's a reason for this. It's called water-specific heat, but basically, water and oceans warm up slower than land. Land can warm up and cool down really fast. Land or water doesn't cool down as fast. So it keeps the climates on these coastlines more mild because it warms them up in the winter and it cools them down in the summer. Mountains can also cause changes in a climate. There's this thing that's called the rain shadow effect, and basically, on one half of the mountain, the windy side where the wind's coming from, it pushes the air up, cools it off, and it creates precipitation. And on the other side, it's called the rain shadow because that air has lost all that water vapor. The leeward, or the side where the wind's not coming from, where the wind's going, it's much drier. You can see prevailing winds depending on where you are on Earth. So if you're in the westerlies, like where we are in Minnesota, depending on where you are with those winds, it can bring different types of air, right? If you're off the coast of Washington, it's going to bring moist air from the west, or from the west, and it gets pushed over the mountains with causing lots of precipitation. But if you go farther east, like on the Great Plains, there's much less precipitation because it's already fallen in the mountains. So basically, where you are and where the winds come from can really affect your climate. Let's see here. There are 3 major climate zones on Earth. We have the tropical zone, the polar zone, and the mid-latitudes. So let's just look at this map. Towards the poles, you have these polar zones, much less sunlight, much colder. At the equator, you have lots of direct sunlight. This is tropical. And then in between, you have your temperate zone, like where Minnesota is, and where the U.S. is. You have your 4 seasons and changes in temperatures. So it's really Arctic, very cold as you go towards the poles. It's like super tropical, hot weather towards the equator, and in between, there's it's a big change. And those are 3 major climate zones. Hey guys, so major things I want you to get is that climate and weather are not the same. So weather can be very different from day to day, and examples of weather events are like thunderstorms or sunny, clear days, things like that. Those are day to day. Temperature can change wildly day to day, right? It can be super hot today. Let's say tomorrow is 80 degrees, which would be really hot for this time of year. And the next day, it could have a high of 55. Those are weather events. Those are day-to-day conditions. Climate's different because it's the average, right? So you have taken the highs and lows and you've averaged them over time. You take averages over a long time, and that gives you what you could expect for a day, because that's the average, but it could be wildly different from day to day. So if you have any questions, let me know with email or hop on to the Google Meet at 10 a.m. on Wednesday. I hope to see you there. I hope you have a great week.